Okay, here's a little help for exercise 9 in the electric field problems, word problems. First step, as usual, is to list your given information. So reading through the problem, you have things like a charge of 6 times 10 to the negative 6 coulombs. The other egg has a charge of 4 times 10 to the negative 6 coulombs. And if you look up here, you'll notice where it talks about centers or 0.4 meters apart. That's really where we're going to be using the equation. This part is part of our unknown. So list out your given information and the unknown variable that we're looking for here, if you read it up top, is what is the electric field. So that is what we're going to be looking for. So looking for E, the electric field. The equation that we're going to use, if you look it up, is very simply E equals force divided by charge. Now the problem is we're not given the force. So if you look at your solved examples, the stuff before this, you can kind of figure out that you're going to have to do a little bit of substitution. You might remember Coulomb's law. Force is K Q1 Q2 over distance squared. So I'm going to take all of that, plug it into here. Okay, keep it simple. Essentially, you're trying to find the electric field for a test charge. So the way that I wrote this out, those cancel, but you got to keep in mind that's just because one of those charges is a test charge. So everything simplifies very nicely. The electric field on one of the charges is equal to K Q2 over D squared. So the way I wrote this, I'm specifically I canceled out one, doesn't really matter. I'm paying attention to this charge, so what I need to do is I need to say, okay, I am finding, that was really bad, I am finding the electric field for charge 2. Left, right, doesn't matter. So whatever, I just happened to cancel out by Q1. And if you're like me, the fact that they mention the charge on the left first, I would just have a tendency to call this Q1. And they mention the other charge on the right, so I would probably call it Q2. So the fact is, if I'm going to stick to that notation, doesn't matter which one you do as long as you keep it consistent, then this charge Q is going to go in here. And the distance between those two charges is going to be your, is not the 0.4. This is where they were saying 0.4 meters to the right. So, you got egg 1, egg 2, just pretend they're eggs, to the right of the egg on the left. So this distance here is the 0.15 meters. So hey, I'll just call that distance 1, and I'll call this distance 2, which is 4 minus 0.15 meters. And that is the distance that I would use in this equation. And if you forget, K is the electrostatic constant of 9 times 10 to the 9th newtons times meter squared over coulomb squared. So this sort of problem is more about accounting than it really is math or physics. Physics is, a lot of it is accounting, keeping track of what's what, keeping it all straight in your head. So now that you've done that, pause this, and I'm going to show the answer next. So go ahead and pause. Yes, pause now. Go ahead. You're still listening, aren't you? Yeah. Okay, so here's the final solution. If you want to work it out, just make sure that you keep your charges the same. Keep track of the subscripts and don't mix them up. So go ahead and pause this so you can check out that answer.